All right, let us finish this. This is where we are. Now, before we left, we worked on the confidence interval for the mean for large samples. Now we're gonna do the same for small samples. Now, when we say that it is the small samples, if the sample size is less than 30, when it's less than 30, we say that it's a small sample. So in that case, we use a slightly different formula to find the confidence interval for the mean. So this section is entitled confidence interval for the mean for small sample. Now, to do this, we're gonna use a different table. That table is called a table of student T distribution table, and it's based on two things: the sample size and the degrees of freedom. The formula we use to find the degrees of freedom is n-1, where n represents the sample size. So I will start by showing you how to use this table, and then we can now go from there. The statistical table that I asked to print, the same table we're using. Now we'll be using table 6, which is the next one here. You can see the student T distribution table. Again, like I said, it is based on sample size and the degree of freedom. If you look at A, as you can see, we have A prime. That is 1 prime for one style, for one side. But for confidence interval, we're looking for the two sides. So we will be using this one that have 2 prime, A with double prime. And these are the confidence level at the top, or they represent the confidence level. For example, here, if you are 90% confidence, your chance of being wrong is 10%, and this is 10% right there. If you're 95% confidence, your chance of being wrong is 5%, which is your alpha. That is 0.05, and so on and so forth. The DF here present the degrees of freedom. You can see them all the way to the last one here, 120. So let me show you how to use this table. The first example we solve asks us to do this. It says to find the T alpha over 2 for the following confidence level. T, we're not using Z anymore because this is a small sample. We use T distribution. So that's why they have it T alpha over 2. Alpha over 2 because you have 2 sides, left side and right side. Okay. Now, first one says find the T alpha over 2 for the following confidence intervals. So I'll put it in the table like this. This one says 95% confidence level with N22. So yeah, if you're 95% confidence, your alpha will be 5%, which is 0.05, because your chance of being wrong is 5%, which is 0.05. In this case, sample size N is 22. Right here. Degree of freedom is N-1. I mean, it's 22 minus 1. So 22 minus 1 is 21. So now we can find the critical value. And look for it under alpha 0.05 in the table. So 21 under alpha 0.05. So go there. 21 You can see the degree of freedom of 21 right here. This 21. I can go under 0.05, which is this one here. So you follow it to 25. So 21, it's right here. 2.080. Write it down. 2.080. And that's it. That is critical value for that. So we go there and put it as our answer. 2.080. Okay. 2 points. Now, we repeat the same thing for 99%. If you're 99%, their chance of being wrong is 1%, which make your alpha 1.01. Sample size is 10 and 10. The degree of freedom is n-1, which means 10-1, which is 9. Then we're looking for under t alpha over 2. The critical value will now become under 9 for alpha 0.01, which is for 99%. We go there and look for it. So you'll find under 9. Let's see, under 9. 9 degrees of freedom. 99% is right here. This one, 0.01. Under 9, this is the degree of freedom of 9. You follow it to that. See right here. You can see 1 degree of freedom. 9 degrees of freedom under 99%. So 3.250. 0.250. So we go 3.250. Okay. 3.25. So this is how to get it. So you can try number part C as a practice. Any question on this? Any question? Good. Unlike the one with Z, that it stays constant. This one varies with the degree, as when the degree of freedom change, the critical value change. Unlike the Z value stay the same regardless of the sample size. So let's apply this. Remember, this is for finding confidence interval when the sample size is small. That means when it is less than 30. Now let's look at one example here. It says I'm going to it says a sample of 6. You can see that 6 is small sample. See, a sample of 6 college wrestlers have an average weight of 276 pounds with a standard deviation of 12 pounds. So A part says find the 90% confidence interval for the true mean weight of all the wrestlers. 90% confidence interval of the true mean weight of all the wrestlers. And B part says if the coach claimed that the average weight of the wrestlers on the team was 310 pounds, would that claim be believable? So then this is a small sample, and we don't know the value of the population standard deviation. So we're using a sample standard deviation of 12 pounds. So that means this is a good candidate for using this student T distribution table, because sample size is small and the population standard deviation, we don't know what it is. So we're using sample. So the first thing, again, I can explain in the other sections will be to list your values. Solution. Okay. And the sample size is 6. Okay. Then say this sample of 6 have an average weight of 276 pounds. So the mean weight is, the sample mean is 276 pounds. So, but because this workbook will not allow us to get the character X bar, let's go to the other workbook and get it. Okay, X bar. Let's get it. You have x bar equation. X bar, it's right here, equals 276 pounds. So I'm gonna copy this. Okay, and on our main workbook. Okay. So press it right here. So remember, this is the solution. And the standard deviation is given as 12 pounds. Okay. 12 pounds. Symbol for standard deviation is right here. 12 pounds. Okay, it is always doing this. They correct it and then make it bigger. 12 pounds. Okay, maybe 14. Even 16. Okay. So now next thing is to find the critical value. Z alpha over 2. This time it is T alpha over 2. So you have T alpha over 2. First of all, let's find our degree of freedom. First of all, our degree of freedom, df, will be n minus 1, and then n is 6, which is 6 minus 1, which is 5. So the critical value now is the T alpha over 2. T alpha over 2 equals, now I can go and look for it. Okay. That will give us some. Look for it on the table. Alpha, okay, it's a 90% confidence. So our alpha actually is, if you say 90% confidence, our alpha will be 10%, which is 0.10. So now we look for it under 5 and alpha of 0.10. So 5 and alpha of 0.10. So this is 0.1 right here. Alpha of 0.10, then 5 degrees of freedom, is 5, and under alpha of 0.10. So that is this. You follow it to the left. So you got 2.015. At T alpha over 2, which is the critical value. Now, once we have this, we're almost done with the calculation of the confidence interval 0.15, so that the 90% confidence interval, the same formula we use. Okay, 9% confidence interval is given by this formula here, which is the right here. S bar minus error less than mean, S bar plus error. So the same formula, just as now you use a different way of getting the critical value. And S bar is the mean, which is the 276 minus error of, we have not calculated the error by mistake. Let's get the error. A mistake again. So our error will be this time not Z alpha over 2, we're gonna be T alpha over 2. I have it here. I don't have it. So let me go and get it from the our workbook, the other workbook. Yeah, I think I will have to go back. So you're gonna be T alpha over 2, the error margin, error. It's gonna be T alpha over 2. Let me write this down, then we'll go and put it in. T alpha over 2 times standard deviation of S over n. And the other thing I put here is I use population standard deviation. It should be sample standard deviation, which is S. Sample standard deviation. So let's go and put this in. This will look like this when after I put it in. Just give me 1 minute. Let me write this down. Okay. About 6. That's N is 6. So let's go and put this in the calculator. It's in the book. Put it in the format that it's supposed to be. So it's gonna be T alpha over 2. Okay, T. Yeah. Error. Sorry, mistake. Error. Okay. E equals to T alpha over 2. Look at alpha right here. Alpha over 2 times, times standard deviation, which is sample standard deviation over the square root of n. Okay, square root of n, sample size. Okay, which is 40 alpha over 2. We got it at 2.015 from the table that we got it from the table, remember? Times the standard deviation of 12, the square root of 6. Okay, square root of 6. So we get this answer, then we go back to our memo book and put it there. So let's look at our calculator. It says here that it's gonna be 0.15 times standard deviation of 12 divided by square root of 6. Then we close it. We got 9.87. 9.87. I put this in. 9.87. 9.87. So I'm gonna copy this. So we can put it in our book, which is here. Okay. So you can see that this is T alpha over 2 is this one here. Sample standard deviation is 12. Sample size n is 6. Again, when you plug them in, you get 9.87. That becomes our error. So that the 90% confidence interval becomes sample mean minus error. And sample mean is 276. Minus error of 9.87. It's less than the mean. So I put this symbol here. Less than the mean. Okay, then less than, we have it here, 276 plus error of 9.87. So that means when you subtract this, I can take you to the calculator to subtract this. So taking you there, and let's see. Okay. I'll take you right there. So I have to move this again. So you got 9.276 minus 9.87. give me 266.13. 0.13, and if you add it, you change it to addition. Let's do both. 285.87. So that means that we can have it that place. So this becomes for this side, you subtract with a calculator, you get 266.13 pounds. Less than copy this, less than the mean which are trying to estimate. Then you can add this to with the calculator. You can verify this because 285.87. So now you have your confidence interval. The conclusion. Conclusion is remember the conclusion. Now let's move it a little bit. Conclusion. So we are 95%. It's 90, I think. So you're 90% confident that the average weight of wrestlers is between 266.13 pounds to 285.13 pounds. So let's conclude this conclusion. So we can say with 90% confidence. That's the true average weight, that the average weight of the wrestlers lies between 266.13 to 285.87 pounds. The sample of 6 wrestlers. So we can see the interval right there. The interval we're looking for. And we can see it in his explanation here. So now, that is how we get it when the sample size is small. Now, what this says, solution for this group of lecturer, he said, if the coach claimed that the average weight of the wrestlers on the team is 310 pounds, would this claim be believable? Well, we have the interval right here. So have it here, write it down. But the coach is saying that somebody in his team is weighing 310 pounds, which is bigger than the interval. Bigger than the interval. So the answer is the claim is not believable. So the answer is the claim is incorrect or not believable because 310 pounds falls outside the interval. Yeah? Questions? Any question?
No, can you keep it there for a second?
Sure. Okay. Gary? Hello?
Yes, thank you.
Welcome. So now, when we come to next week, we start from confidence interval for proportion. Now, let me check your attendance so we can leave. Now, your classwork 9, which will be is now available on the screen. So on the classwork section of the homework in the Canvas. So you can do it and then upload I'm gonna use it to populate your class of 8 and 9. And because I got some names here, but I didn't get others. How about this person, Tashira Allen? Are you there? Tashira Allen, there? Begley Shade. Shade Begley. Yeah. Noah Bowen. Leroy Gunston. Can you hear me? Hello.
Yes, I can hear you.
Yes.
Arrington Jasmine.
I'm here, Professor.
Arbota Samuel Arbota, are you there?
Here.
So when I call you, you can leave. So except if you have question.
Have a good one.
You too. Justin Battle.
Here.
Leroy Granston. Janelle Hawkins. Christopher Jeffries. Canis Johnson. Okay. I have 14 people here. Hashiba, I think I see it. Hashiba, you there?
Yeah, I'm here.
Olivia Hamilton. Zukinas Johnson. Johnson is Zukinas. Zukinas, cannot there. I got Seven Jones.
Here.
Shiru Kimani.
Here.
Lasta Ian Lasta. Kayla McKee.
Yeah.
So after I call you, can feel free to leave. Babakar Mboji. There. Musamasha.
Here.
You said Chaton?
So is that okay? Okay, Shaton Pickering, yeah.
Yes, here. Okay. Have a good night.
Two. Jaden Pearson.
I'm here.
You here? Okay, okay. Ivy Russell.
I'm here.
Good. And who else? One person, two person actually. Taylor Raymond. Yeah. All right. I see you guys next week.
You didn't say my name.
You
Yeah.
didn't say my name either.
What's your name?
Naisha Salamani.
Oh, I marked you already. That's why I didn't call you.
Okay.
Professor, I have a couple of questions.
Go ahead.
Same.
I missed the homework from last week. Will you be able to reopen that for
I
me?
thought I did. What's your
Huh?
name?
Jasmine Arrington.
Send me an email now so I can check your attendance, and then if it is good, I'll open it for you.
Okay.
Same.
You're talking about
same goes.
you're talking about the homework in my
That was
lab, my math lab, right?
yeah, that was due last Sunday.
Yeah, send me email. State the name of the homeworks. If it's
Okay.
homework, whichever it is, let me put it on the email.
And we have a test due on Monday. Now, what topics are going to be covered on the test?
Let's cover the one we did before, not what we did today. One we did before today, starting from probability to the binomial and then normal distribution.
So, was anything from the last homework on it?
No.
So, what homeworks cover that, just so I can like review?
You mean homework?
Yeah, like what homeworks like cover the topics that are going to be on the test?
Oh,
Because
is
we
this
have a
homework-
total of 7 homeworks, right? So
Is the homework? Hold on.
would it be homeworks like 5 and 6 or?
Give me 1 minute. Let me just 1 minute. Let me put them up. It gotta be 1 minute. I go to your class.
Okay.
I see it right here. A minute.
Mhm.
You're gonna be homework that covered it. In the class with the homework. Homework 5, 6, and 7.
5, 6, and 7. Okay.
Yeah. Probability, discrete probability distribution, and then normal distribution. That's what you see on the test.
And do you have office hours?
Yeah, it's by appointment. But this week, that's one of the reasons I wasn't here in the class now, because I couldn't make it.
Uh-huh.
Yeah.
So no office hours for this upcoming week?
This week I don't have not for this week.
Okay. And classwork 9, is that due April 17th? Like all the other
I moved it to next week so that you have enough time.
Okay, so all the classworks are due next week then?
Not all the classwork, just classwork for this week, and the homework 8, classwork I think it's classwork 9, I believe.
Uh-huh.
Yeah, 9. Okay, I still have assignments.
No,
For
the classwork 9, when is that due?
next week.
Next week? Okay.
I moved to next week so that you have time.
And when I clicked on classwork 8, like nothing showed up. Like
No, remember I said classwork 9, that's what you're gonna click. Because classwork 9 we take care of 9 and 8.
Okay. All right, thank you.
Welcome. All right, guys, I'll let you go.
Professor, I still have a question.
Yep, go ahead.
You didn't call my name for attendance.
Actually, I marked you. This is Dejani, right?
No, this is Anaya.
Anaya. Last name?
Statham.
Yeah, actually, Statham, I called you. Sorry, my mistake. I checked you already. That's why I didn't call you.
Oh, okay, cool. And then the same goes for me for homework 7. I wasn't able to get it. Can you reopen it for me, please?
The one I opened for you last time, Anaya?
No.
It's not the email.
Oh, no, it was the recent homework that was due last Sunday.
Send me an email, put the name so I have to open it for you.
Okay, thank you.
But I'm going to look at the attendance though.
Okay.
Did you want me to send you another email as well?
If you can, that will help. I want to
Okay.
do it now so I won't forget again.
Okay, thank you.
Welcome. And I'm gonna check my email now. All right, see you guys next week.